to Math Alberta today. I'm happy to see you. There is a question here we want to look at under integration by trigonometric substitution. All right, so we have a question before us. They say we should evaluate integral of sine inverse of x all over 1 all over the square root of 1 minus s squared. So this is what we want to integrate with respect to x. All right, so we have a question here together. Now, the first line of action here, please listen attentively, is look at the denominator carefully. If you look at this, you will discover something. Look at it carefully. You discover something. That, okay, every time you are differentiating a function, integrating a function rather, and you have something like this, and you have something like a squared minus s squared, where this a is a constant. Constant means that this a is a number. The trigonometric substitution you are meant to do is to say, or if you have it like this, or you have 1 all over something like a squared minus s squared. It can be 4 here, it can be 9, it can be whatever number. Okay? Anytime you have something like either this one or this one, you are going to say, let s be equal to a sine theta. Where did you get a from? The square root of this one, of a squared will give you a, then sine theta. All right, so if you look very carefully, we can make this denominator to resemble this thing here. How? Look at it. Let me show you how you can make the denominator to resemble what I just said now, so that assumption can commence. All right, so we go. All right, so we go. I'm going to say that this is equal to integral of sine inverse of x all over here. I write it as 1 squared minus s squared dx. I want to be sure that you can agree with me that what we have now is looking like what I said, right? A squared, square root of a squared minus s squared, where a is a constant. Okay, so now that we have been able to make it like this, we are going to say that what? We are going to say, let x be called, a in this case now will be 1. Square root of 1 squared, or square root of 1 is 1. All right, so x is equal to 1 sine theta. Just say x is equal to sine theta. Since here is 1, assuming it's 9 here, I will say x is equal to 3 sine theta, because the square root of the 9 will be 3. If here were to be 16, I will say x is equal to what? 4 sine theta, and the case may be. Now, after this assumption, see the next thing to do. Now, make theta the subject of the formula. All right? If you make theta the subject of the formula, it means that what? That sine inverse of x is equal to theta. Is that okay? Sine inverse of x is equal to theta. All right? So, that is for the first one. Now, another thing can still be done in this place where you have s is equal to what? S is equal to sine theta. Now, what do? Now, differentiate x with respect to theta. Write it as dx, dx the theta. If you differentiate sine theta, you're going to get cos theta. I hope you are following. All right. Now, make dx the subject of the formula. If you do that, multiply both sides by the theta. All right. So what I mean is, we have dx over the theta multiplied by the theta is equal to what? Cos theta multiplied by the theta. That means this cancels this for you, and dx is actually cos theta the theta. That means that the original expression will reduce to something else. Original expression or integral, which is integral of sine inverse of x all over the square root of 1 minus s squared dx will now become, just follow carefully, it will now become integral of, instead of sine theta now, what do you think is the equivalent of sine theta? Sorry, sine inverse of x now. What's the equivalent? It's just theta that is the equivalent of that one. So you write theta at the numerator. Then at the denominator, you are going to have, let me shift it this way. At the denominator, you are going to have square root of 1 minus, instead of x now, what do you write? You are going to write sine theta for in place of, so you are going to have sine theta all squared like this. Now multiply by, instead of dx now, dx is now cos theta d theta. So we have cos theta d theta. Is that okay? All right. So we go on. The next line of action now is to, so we are here, is to have integral of theta, okay, all over square root of 1 minus, this place can be written as sine squared theta. Yes, sine theta all square in mathematics can be written as sine squared theta. We put the square on the sign before the theta. All right, then multiply by cos theta d theta. Okay, now, but there is an identity that 1 minus sine squared theta is equal to cos squared theta. 1 minus sine squared theta is equal to cos squared theta. Look at where the thing came from. Look at where that identity came from. The identity came from sine squared theta plus cos squared theta equal 1. So for us to have this kind of this thing, what do we move? We move this one over. This is an identity. Every time you have sine squared something plus cos squared something, you are meant to get 1. All right, so move this one over. That means that the cos squared theta is the same thing as 1 minus sine squared theta. Is that okay? All right, so that means that when we have this thing now, we can plug only this one for it. Look at it. All right, so we can go on now. We can plug this for it. So everything becomes integral of theta all over. So this one minus this one will now give us square root of cos squared theta. Then multiply by cos theta d theta. All right, so let's just keep going. Remember, I brought in this other one just for you to understand how I got that step, not necessarily that is part of the solution. Okay, all right. So now this one can be written as integral of theta all over. This one can be written as square root of cos theta all squared multiplied by cos theta d theta. So we're almost done. Just try and follow on. We're almost done. All right. So now this square, we cancel this square root for you so that you now have integral of theta all over. You now have just cos theta under at the denominator multiplied by cos theta d theta. All right. So as you are multiplying cos theta, we cancel cos theta for you. So everything now has become has reduced to what? To just integral of theta the theta. So you can go ahead and manipulate this one a little by writing it as well. Integral of theta to power 1 the theta is equal to what? Now we now integrate. Once you start your integration process, you can go ahead and remove the integral sign. All right, so integration is all about adding 1 to the power dividing by the total power. So if we integrate theta raised to power 1, it means it will not be theta raised to power 1 plus 1 will be 2 all over 2 plus a constant of integration. And then finally, we need to recall what this theta represents. So recall that theta represents sine inverse of x, right? All right, so we are not going to say that therefore the final answer now is what? Therefore, integral of sine inverse of x all over the square root of 1 minus x squared dx is now equal to, so we put the answer, our answer here and arrange it. So we're going to have sine inverse of x all squared, divide the answer by 2. then plus a constant of integration. Please, on no account, you cancel this against this. It's wrong if you do that. If you do that. The only thing you can do here is to, if you don't want it this way, you can bring the 1 over 2 outside and now say sine inverse of x all squared plus c. So this is our answer. This is how we integrate a function of this kind. If a function has, we check and see if a function appear in the form something square, a number square minus an alphabet square like this, or 1 over the square root of an alphabet square a and this square. The appropriate trigonometric substitution you are meant to do is to say s should be equal to what? A sine theta. And then you now carry on from there. All right. Thank you for staying up till now. But I want to give you something to be sure that all what I have taught has been properly understood. All right. So you're going to have this.